Good evening and welcome to today's Tropics for July 28th, 2020. Please note, I'm not a meteorologist and this video is just a collection of my thoughts and opinions about the storm I'm talking about. For any decision making, please consult the National Hurricane Center and your local officials. So today I'm looking at potential Tropical Cyclone 9. So we now have quite a few tropical storm warnings, and for those warnings to be issued, you needed some sort of a system for with advisories, and that's why I have potential tropical cyclone. Not quite an indication that it's a well-organized tropical cyclone right now. I had recon go in earlier today. Didn't sample too much on the western side where the convection is, but it doesn't really seem that even there we have anything well defined. It does seem that this elongated, slightly tilted northeast to southwest wave that we've been looking at. It is trying to tilt a bit more north-south, and you can see that a bit more with the flow in the on the eastern side here, and that's a bit more south-southwesterly as opposed to west-southwesterly or just southwesterly that we have been seeing. So it's trying to tilt a bit more upright as some of the models expected. And then there's a little mid-level center here. It's probably not going to do anything because it's diving to the southwest. But it's a cool little thing to look at. It was from deep convection earlier today, but that has since pretty much dissipated, and now it's up a bit more here. Looking at the infrared imagery, you can see that there's still that stronger convection on the west side. But there isn't as impressive convection on the east side, and that's what we continue to see. It doesn't seem that either side is super favored at this point anymore. The west side is a bit more sheared and also doesn't have some of the spin that the east side has, but the east side doesn't really have convection, so it seems that there's going to be something close to the middle that we're going to try to watch, but it's still a very broad system, so it's hard to tell exactly where that low-level center will get together. One thing is relatively high confidence, and that's one impact coming soon. You can see that there's very strong winds aloft. This is 700 millibars. You can see there's very strong winds at that level, and in some areas 50 knots. And that's actually why there's flight level hurricane force winds on the recon mission, because it flew through this wind area of strong wind. And with convection over that area starting now, you might see some of that strong wind in that level start to get brought down to the surface. Maybe not those 50 knot values, but that means you might start seeing stronger winds, such as tropical storm force, or in a larger area and stronger. So I'll have to see if that does happen, but that might mean some slightly stronger winds for Leeward Islands and Puerto Rico as it gets into that area. Other than that, we're still dealing with major uncertainty with regard to how strong the storm is going to be and where it's going to go. And it seems that next 48 hours or so are going to be integral to actually see what exactly the storm does. I'm choosing to look at two different models here. Here's a GFS, which is generally weak with it. At this run, it takes it down to 1,000 millibars. It was a lot weaker earlier, so it is trending slowly stronger, but is generally weak. Also, the GFS parallel, so this is one that's undergoing testing, and eventually will replace the GFS. So there's actually two different versions of the same model running, and it's definitely two different camps. This one weak, and this one much stronger. And you can see that these trends here, you can see it's weaker on the GFS once it actually gets to the Northern Caribbean, but it's quite a bit stronger on the GFS parallel. It's about 1,000 millibars. And then looking at the upper level wind, this is one thing that is a big difference between the two, but a very subtle difference between the two. And you can see this is when it peaks around 1,000 millibars, but it starts weakening going into the Bahamas and traveling a bit more north. And that's because it's displaced from this upper level anticyclone here. And what that is doing to it is it's pushing some southerly wind aloft into the storm, but it looks like the storm is just too weak at this point and hasn't really strengthened too much. So it gets sheared by this, and that means if you have shear over the cyclone, it's hard to intensify much at all, especially with the dry air around. But there's a subtle difference with the GFS parallel. It's a bit stronger, so it seems that even though it's displaced from the same cyclone or anticyclone aloft here, see they do look quite similar. The GFS parallel actually has this become more of an outflow kind of thing where you have upper level divergence, and that would actually help the convection quite a bit, and that would help the storm organize. And you can see it's a bit stronger here, but unlike the GFS, which slowly weakens it up into here, or up into the northern Bahamas, the GFS parallel actually makes it a bit stronger. And here's another reason why you see that. And that's because there is quite a bit of dry air to the west. You do have this tap of more moist air coming out of the Caribbean here, but the shear that's going into the system based on this means that you advect, or pretty much forcibly advect that dry air into the system, and without much of a core, that basically is forced into the system, and that means everything is over here. So make it convection trying to fire over here, but that means up shear, it's going to have a very hard time with dry air and shear for anything to fire, and that means it's going to convectively struggle, and that's why the GFS makes it weaker going into the northern Bahamas. But the GFS parallel here, you can see it has very similar features. It has that a tap of moisture air from the Caribbean, but also towards the west, it also has that drier air. However, it's closed off a core here, and that means it's able to insulate itself. And again, this is more outflow or enhancement than shear in the operational GFS. So that means that the dry air has a harder time getting in because there's an actual inner core that's trying to be built at this time, and at the same time, it's not your usual shear. It's more like an enhancement to the storm's outflow. It's pretty easy to see what these differences mean on Saturday afternoon. The operational GFS has PTC 9 struggle, and that means it's only at 1,002 millibars, and it's a weak tropical storm in this area of the Bahamas, and I'd definitely rather this because these are the same islands here that were impacted by Hurricane Dorian last year stalling. So if you can get a weak system over here, that would be preferred to the GFS parallel, which in that more favorable environment is able to actually form a much stronger storm, 979 millibars, and it looks like this is more like a hurricane rather than a weak tropical storm here. And that would be a bad thing for those islands because they have just gotten a very, very bad hit last year, and we don't want them to have another hurricane, even a weaker one, hitting it again only a year later. Looking at steering, so this is also uncertain. There has been a west trend in models, actually. They've been continuously trending west and faster with PTC 9, and that means given that both these models closely miss Hispaniola, so you have the GFS parallels over Puerto Rico, and you have the GFS, it's a bit further west, but you see that they both miss Hispaniola, and if we have a more west trend, if you have it run into this island, that means it's probably going to shred up its vortex, the low levels, and it's probably not going to do much beyond this, because if it's pretty much dissipated from the mountains here, that means the conditions here are almost guaranteed to be unfavorable, so it's likely we almost get no system. So we'll have to see if it does run into this island. But if it doesn't, whatever PTC 9 is in the Bahamas here, we'll have to watch this trough because it might be able to pick up PTC 9 and bring it up to the north. However, given that faster trend, it's also trended west towards more Bahamas and possibly Florida. So hopefully we can get a recurve out of this, but it does seem that's going to impact more land, and it's looking less likely that we'll get a recurve. But hopefully we end up getting that, and it's not mostly harmless outside of the places it's already likely to impact. Now, looking at just two models may make it a bit misleading because those are only two scenarios. But looking at the ensembles of a model makes it a bit easier to see what the actual scenarios are. And I'm going to look at two different ones here, the Euro ensembles, which are generally weaker but have a few stronger members like this one. And the GFS ensemble, which is a bit further east, probably because it is a bit more bullish than the Euro ensembles, but you can see basically it's weaker, that means it's more southwest. If it's stronger, that means more northeast. And it's likely these ones in the Gulf here are members that tracked over or near Hispaniola, and that means they're very weak and can't really do much, and that means they don't really get picked up by that trough, and they end up in this region. But if you have stronger storms that feel some more of that troughiness to the north, and that means it's further east, so you have the stronger members that are like tropical storms hitting, say, eastern Florida, but then you have the strongest member here that goes through the Bahamas, but doesn't is much further east than many of them, and makes landfall in the Outer Banks. And with the GFS here, or GFS ensembles here, you can see similar weaker ones are to the west here, but the stronger ones go more to the right or to the east. And again, hopefully we can get a recurve out of here, but it's quite uncertain still. But it doesn't look like once we get out of here and north of the islands or Greater Antilles, we'll have a better idea of what it's going to do. But it does seem that stronger goes further north and vice versa. So looking at the official National Hurricane Center cone, you can see there's a large area of tropical storm warnings, and that's because this is a large storm. Even though it's only 40 miles an hour, it's already caught this large bubble of tropical storm force winds, and that is just testament to how broad the system is. And that means the impacts are likely in all of these regions in the form of high wind. And what the National Hurricane Center does with this, takes it to a 60-mile-an-hour tropical storm and pretty much stalls out the intensity in this region before starting to weaken over land in Florida. And what they're doing, it looks like splitting the difference between the stronger scenarios and the weaker. And that's a pretty smart decision, because you don't want to go one way or the other, but it doesn't look like we're going to have this sort of middle ground scenario. Is likely going to bust one way or the other, because if it is rather weak going in this region, it's going to continue to weaken. But if it's stronger, then it's going to have an opportunity to strengthen. But definitely it looks like they're taking the middle approach and making it a mid-grade tropical storm. But again, hopefully it's weaker so that we don't already have a bad tropical cyclone impact this early in the season. Still, regardless, this area will likely see some impacts, along with possibly the Bahamas. And these impacts are in the form of gusty winds and heavy rain. So you might see high winds and possible flooding, no matter if PTC 9 ends up developing or not. Otherwise, there isn't. The tropics aren't too active. The West Pacific is trying to wake up a little, but it's only a couple of invests at the moment. Douglas continues to weaken as it's sheared and is traveling to the west. If you have any questions or comments about my video, please let me know, and thanks for watching.